Hey everyone, it's Mr. Aaron's. Today we're going to be doing a little bit more with exponents. We're going to be talking about multiplying them today. You need to get started on a worksheet, and then tomorrow you are going to work on dividing them and finish that worksheet. Let's dive in. Okay. So we got exponents and multiplication. Right here. Perfect. The first thing I want to talk about is, I mentioned this before, but if you don't have it in your notes, today is a great day to get in your notes. We got our base and our exponent. Those are two different parts when we're talking about exponents. Our base is going to be our bigger number. It's going to be the lower number. Our exponent's that smaller number up top. Our base tells us what number we're multiplying. Our exponent tells us how many times. So right here, this would be telling us we're multiplying 7 2 times, or 7 times 7, 7 2 times. Our answer for this would be 49. A quick rule, if you don't have this in your notes, good time to jot that down as well. It's if there is no exponent, that means that there is an imaginary 1 sitting there. Also, you can see right here, 7 is the same as 7 to the first power. I'll show you that right now. 7 to the first power would just be 7 times itself 1 time. There it is, just 7. So if you don't have an exponent there, you can imagine that there's a 1. Right now you might be like, well, why does that matter? Well, I'll show you in a second here. We have some cool rules when we are multiplying powers with the same base. So we're talking things with the same base. So 7s, or in this case down here if you're looking ahead, I've got 2 right here, 2 right here. They have the same base. They have different exponents. So if you have two numbers that have the same base but different exponents and you are multiplying them, there's a cool way, pretty easy way that we can do that right here. I'm going to show you two different methods. The first one is the spread then add. The second one is going to be the match and add, and match and add actually has a formula for it right here. So if you want to jot that down real quick, you're welcome to do that. So our first one is our spread and add. This is something that we're a little bit familiar with. We have this 2 to the third power times 2 to the fourth power. So watch what I'm going to do. I'm going to take this 2 to the third power, and I'm going to make it a 2 times 2 times 2, 3 times. And we're going to multiply that by 2 to the fourth power, which is 2 times 2 times 2 times 2. Now, if we look at what we have here, we really pinch these together right here, pull them together. We have 2 times 2 times 2 times 2 times 2 times 2 times 2. Or, count those 2 ups. 2 is up, and we got 2 to the 7th power. 1, 2, 3, 4, 5, 6, 7. I spread these apart. I spread up my 2 to the third, split it up. Times 2 to the fourth, split it up. If we look at that all together, it's really just 2 times 2 times 2 times 2. I lost count. 7 times. We reconnected those up here. That's our spread, then add. We add them up. We count up that there were 7 of them. 2 to the 7th power. Now there's a little bit easier way you can do this. It's a little quicker, a little faster. If you like this method, then you should run that. If not, I got a quick tip for you right here. If we have this right here, watch what's going to happen. Here's my formula over here. We got a to the m, so they have matching bases. That's always important. They have to have matching bases, otherwise we can't do this. Then look at what happens. A to the m plus n. We're going to take these two and we're just going to add them up. Look at this. We got a 2 as our base. We know it's going to stay our base. A 3 plus 4 is what? 7. Well, look at that. 3 plus 4 is 7. 2 to the 7th power. That's what we got when we split them all up, too. You can take these exponents when you're multiplying, and you can just add them together. If they have the same base, you can just add them together. The key is they have to have that same base. If they don't have the same base, you can't do this. You cannot multiply them like that if you got the same base. All right, so we got a couple examples here. Our first one down here. We got 0.3 to the what power? Don't say 0. Don't say 0. We talked about this. If there's no exponent, that means there's an imaginary 1. I'm going to toss it in there. Times 0.3 to the third power. Well, let's start with our spread then add method here. It's going to be 0.3 one time times 0.3 three times. Oh, we got a lot of decimals here, making it confusing. What do I really have here? I have 1, 2, 3, 4, 0.3 to the fourth power. Easy. Spread those up, add them up. Our second method is our match and add. We see we have a 1 here. We see we have a 3 there. So let's do 0.3. That is a weird 3. 0.3 to the first times 0.3 to the third. Add up these right here. Gets us to 4. 0.3 to the fourth. Use whatever method you like more. Don't get caught up on this next one. We got to look at it right away. I noticed something. I have a to the fifth times a to the, what power would that be? Look at our special rule up here. If there's no exponent, that means there's an imaginary 1. Let's toss it in. Times b to the second. Uh-oh. This b right here, something's wrong with that. It is not the same base. We cannot do that as part of ours. It doesn't have the same base. We can't follow these multiplying rules. But we can do it with these. They have the same base. They're both a's as our base. Remember, our big number is our base. Our small numbers are exponents. So we can do those. So let's start by the split up method here. I'm going to do a to the, oops, I didn't mean to write anything above that. I'm just going to do a times a times a times a times a. There's our a to the fifth. We got our a to the first times a times b times b. You know how to do the rest. Connect those back up. We got 1, 2, 3, 4, 5, 6. A to the sixth, b to the second. Nice. Now if we do our match and add method, we got a to the fifth times a to the first times b to the second. They have to have the same base. They have to have the same base. Which ones do? These ones do right here. Let's add those up. A plus 5 plus 1 is a to the sixth times b to the second. We can't put b in there because it is a different base. I got 2 more examples like that. On our next page here, we got 6 to the third times 6 to the 12th. Ooh, there's going to be a lot of splitting up here. This is where it might get a little easier to use my second method. So let's start by splitting this one up. We got 6 times 6 times 6. There's that. Over here, we've got 6 times 6. So this one's going to take a while. See if I have enough room. There's 5, 6, 7, 8, 9, 10, 11, 12. Oops, I went a little bit into the next one. That's okay. Now you're starting to see why the second method might be better here. Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 6 to the 15th power. But let's make this simpler. I don't want to write all those 6's. I just want to do 6 to the third times 6 to the 12th. They have the same base. Let's add them up. 3 plus 12 equals 15. Wow, look at that. That's nice and easy. Use whatever method works best for you. One more example like this. All right, we've got m to the fifth times n to the second times m to the third. Okay, let's do it. Split this first one up. Let's do m times m times m times m times m. There's 5 m's times n times n. We got 2 n's there. How many m's again? We got 3 more. Times m times m. Now we got to reconstruct this. Let's count up how many m's we have. 1, 2, 3, 4, 5, 6, 7, 8. M to the eighth. N to the second. Done right there. We can do our add up method. We can still do this. With our commutative property, we're allowed to rearrange this and make it m to the fifth times m to the third times n to the second. I'm doing that to get all of my same bases by each other. Now that I have that done, let's add these up right here. That becomes m to the eighth. And we can't add on because it has a different base. Remember that base, these two are matchers. This one is not. N doesn't go with those m's. It's a different base. All right. We're now looking at evaluating with PEMDAS. These are going to be some things that you've seen before. We got those 4, and they tell us what to put in. So what are we going to do? We're going to do exactly that. We got 5x to the second power plus 3y to the third power minus x times y, for x equals 3, y equals 2. So what are we going to do with these? We're going to plug them right in. Let's do it. Every time I see an x, I'm going to plug in that 3. Every time I see a y, I'm going to plug in a 2. Okay, and now we start thinking about our PEMDAS. First step, parentheses. I look in my parentheses. Everything in parentheses is already solved. There's nothing to solve. Next step, exponents. I got a few exponents, so we're going to start with those. We're going to write this as 5 times 3 to the second power is the same as 3 times 3, which I know is 9. So I'm going to write this as 5 times 9 plus 3. 2 to the third power, we got 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 3 times 8 minus 3 times 2. Okay, we're on to our multiplication. Let's do this. We got 5 times 9 is 45, plus 3 times 8 is 24, minus 2 times 3 is 6. From here, we can do the rest. This is going to get us to 69 minus 6, and that'll leave us with an answer of 63. Follow those PEMDAS rules. Important once we get those exponents in there. All right, next one. They give us negative 6j squared, or to the second power, minus 2m plus m to the third power times j. They tell us j is equal to 4, m is equal to 2. We're going to take those, plug them into our formula here. Negative 6, 4 squared. I'm going to plug in that m here. Notice I'm putting those all in parentheses. Makes it a little easier for me to solve personally. Now we hop into our PEMDAS. First up, parentheses. I look in my parentheses. They're already solved. There's just a number. Second up, exponents. Okay, we got one right here. Let's do it. 4 to the second power. That's 4 times 4. I know that is 16. And I got 16 times 6 minus none there, plus 2 to the third power. That's going to be 2 times 2 times 2. I already did that one up here. I remember that's 8. And we got that 4 at the end. Now we're on to our multiplication. Start by 6 times 16. We go from left to right. Left to right, left to right. 6 times 16. Jot that one down. I got a negative 6, so I got to remember it's a negative. 16 times 6. 6, carry that. 6, 96. Negative 96. Negative 96 minus 2 times 2 is 4. Plus 8 times 4 is going to be, let's see here, 32. Okay, last step. We're doing that addition, subtraction from left to right. Negative 96 minus 4 is going to be negative 100. I minus 4 more from that. Plus 32 gets me to, let's see if I can do some mental math here. Hope I don't mess up. That's going to be 68 negative. Because I got more negatives than I do positives. All right, last one, then I'll send you on your way. This one, they don't tell us a 4, so we're not going to be able to solve it all the way because we have this exponent in here, but they didn't tell us what it's going to be equal to. So we're just going to simplify this one. We're still going to follow those PEMDA rules, though. Start out with our parentheses. All right, here we got some, but we can't do anything with those. We can't do 5x minus 2. That's already simple as it can be. Next up, we got exponents. Okay, I got one right here. Negative 2 to the third. That's going to be negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4 times another negative 2 is going to get us to negative 8. Okay, we got negative 8 on the end here. So now we got 6 plus 4, 5x minus 2 times negative 8. Okay, now we got our multiplication from left to right. I see right here I got something special. I'm going to distribute that. Anytime I see something that's looking like this, I know that means distribute. We're going to do 6 plus, that's going to become 20x, 4 times 5x, minus 4 times 2 is 8, times negative 8. So we got all this right here. For the sake of time right now, I'm going to make this into an add instead. Sorry if that confuses you right now, but I just don't want to have to go through all that right now because I know you know how to do it. So I'm going to make this into an addition sign. I'm going to rewrite this as 6 plus 20x minus 8 plus negative 8. That's how I'm going to rewrite that for the sake of time. And finally, simplify here, rearrange some stuff. We could take this, move it to the back, make it a plus 6 over here because we know it's positive. 20x minus 8 plus another minus 8 is going to be negative 16 plus 6. It's going to move us back towards positives, just positive 10. And that's going to be our final answer here. I know I switched up that last problem. If that confused you, don't worry about it too much. You won't have anything like that on your homework anyway. All right, you're going to take time on that first half of the worksheet. We'll do the second side of it tomorrow. There you go. Exponents.